Hello ladies and gentlemen, welcome back. This is Ms. Dubois doing a quick video for the final family of topics that are in pre-algebra goal 4. Had a typo in the last video, thought I was at the last family, finished up my recording, wrapped, uploaded everything, and then I found this and I made a Homer Simpson noise. So moving on. Now we actually get to some of the fun stuff. You see how it says multi-step equations? Low-key, this is my favorite. It makes me smile every time I see it. When I talk about how I love math and it's something that's very fun for me, this is exactly what I'm talking about. So first things first, we're going to scroll down a little bit, get an idea for what we're doing. You'll notice how it says simplify your answer as much as possible. We don't technically need to worry about that because the act of solving is actually going to do the simplification for you. Now, what's going to happen is we're going to use all of our skills in the prior video compilations in order to do this. And I can see automatically I have parentheses here, so I'm going to use my old friend, the distributive property. 3 times 3 is 9, and y is just sitting there chilling. It's not ready for its time yet. 3 times 4 is going to be 12, and then the 51 drops down. And now suddenly I have a two-step. This is what we were doing in the last video. And just in case you forgot, we're going to be doing PEMDAS in reverse. So we're going up and we start with undoing our addition and subtraction first. So that minus 12 needs to go away. So we're going to add 12, and we're left with 9y. It drops down, and then 51 plus 12 is 63. And then the next step is going to be, let's see here, we did our addition and subtraction, so now we're going to move on to multiplication and division. That's 9 times y. The opposite of multiplication is division, and so we divide, and so we divide. We're left with y equals 7. So when they say simplify your answer as much as possible, the act of solving actually gets you your most simple or simplified answer. Now we go through it again. 3 times 3, 9u. 3 times negative 5 is negative 15, and then the 12 drops down because it hasn't done a thing yet. Let's see here, we undo this subtraction. The opposite of subtraction is addition, so we're going to add 15 and add 15. 9u drops down. U isn't being used yet, it's just vibing, so it's going to be 27. And then undo that invisible times symbol with division. Undo with division, u equals 3. There we go. And for our next one, we have 3 times 3 again. Weird screen grabs. 3 times 3 is 9. 3 times 6 is going to be negative 18 because again the minus sign drops down, equals 18. Okay, I'm a little nervous because there's two 18s there, but let's see what happens. This is subtraction. We undo subtraction with addition, so we're going to add 18, add 18, 9x equals 36. Okay, good, I'm less worried now. This is multiplication. I undo multiplication with division, and we're left with x equals 4. So this is now what we mean by multi-step. You've had a one-step, where it's something like x plus 3 equals 8, and you can solve it in exactly one step. You have a two-step equation, which I can't spell, so something like 2x minus 5 equals 7, and you'd go through the effort to find out that x equals 6, and you would do it in exactly 2 steps. You'd be undoing the addition and subtraction, and then the multiplication. And here now, what's happening is we're doing the officially titled multi-step. Multi, if you remember, means 3 or more, so this means multiple steps. So there's step 1, where this is step 1. Can't even read my own handwriting, Ms. Dubois. That's step 1, where we take care of the distribution. Step 2 is moving the 18, and then step 3 is the division. And when you get really, I don't know if we'll get there in this particular video, but especially in Algebra 1 and especially in Algebra 2, you get these really beautifully long, complicated equations, and it's very fun to do. It takes like 6, 7, 8 steps. Like, I'm not going to say that it's short, but because it's such small little steps that you do, Ms. Dubois gets a happy little feeling in her heart. All right. Next up, make sure we're going to round off some of our skills. Two-step equations, so we're back to only doing things in 2 steps. But now we're just using up our other skills from goals 1 and 2, so we're going to be dealing with our decimals. So, and as a reminder, because I see some fractions here, remember, even though this is a fraction, because it's algebra, we're not going to read it as a fraction. Instead, we're going to read it as division, and that should visually and mentally help you feel more confident when you're going through this. But since it's division, we're not doing it yet. Ergo, the first thing we're going to move is that 1.1. Since the sign of it is negative, the opposite of that is positive. And so we're going to add 1.1, add 1.1. U over 3 equals. So these are opposite signs because the 20 is negative and the 1 is positive. Opposite signs you're going to be subtracting. 20 is the bigger number, so that's the sign that dominates. So that's going to be 19.2. And then that's division. And like we were saying, because we're reading it as division, the opposite of that is multiplication. Times 3 times 3. So U is going to equal negative, let's see if I can do this in my head, 57.6. That wasn't too bad. Decimals are my weakness. If I get it wrong, you can let me know in the comments. Next one. All right, so we're going to, again, we're doing our PEMDAS in reverse. I'll keep it as a rolling comment. We're going in reverse, so we undo our addition and subtraction first. This 11.5 here is positive, so we undo that. The opposite of a positive is a negative, so we're going to subtract 11.5, subtract 11.5. Now you'll notice that these are both negatives. Since it's the same sign, we're going to add them, which is going to be, of course, negative 12.8. And now we undo the division. So we're going to oh my God, we're going to undo the division with multiplication. I promise I can talk. Good Lord. Times 8. Let's see if I can do that in my head. Wish me luck. Let's see here. That's going to be 96, which becomes 3, 2, 4, negative 324. Or no, there's a decimal there. So negative 32.4. Maybe. No, that doesn't sound right. Okay, I will leave you guys to let me know in the comments if I did my math wrong. In my defense, I'm doing it in my head. Okay, over here, again, PEMDAS in reverse. So that 2.4 is a negative, and therefore we undo it with a plus 2.4, plus 2.4. 3U drops down because it's just chilling. This is just straight up addition. I don't have to think too hard, so that's going to be 9.6. And now we divide by 3 because that's multiplication, and the opposite of multiplication is division. U becomes 3.2. Now theoretically, between the last video and this video, you've been solving these equations multiple times, and you've been doing the topics also multiple times, so this should be all hat. There's nothing really new here. You're just doing the same steps over and over, which is theoretically gives you some confidence. Now, identifying properties. Now, because of the screen grabs, I don't have the ability to have a drop down. There's a decent list that you're pulling from, but the real important thing I'm going to label is say you want to keep track kind of the right-hand side of the equation. So this side of the equation. When you see an operation being done, then you name the thing. You see the thing, you name the thing. So in this case, that's the little fraction bar. But remember, it's not a fraction bar in algebra, it is division. So you would choose division as your answer, division, for this particular thing. Over here, that's plus 1. You see a thing, you name a thing. This one is going to be addition. The thing that will be new for some students, and you've seen it actually being done up in here a little bit, is now we actually do the thing. So you see the thing, division. Here we actually did the thing. 18 divided by 6 is 3. When you see the thing, name it. Do the thing, simplify. Simplify. Here, same thing. We had negative 3 plus 1, and then we did the thing to get negative 2. So that's simplify. Simplify. Well, what if the equation is slightly more complicated? Over here, you'll notice, and we were talking about this in a prior topic, we had those parentheses, and then the parentheses completely disappeared. When parentheses disappear, that is the distributive property. Distributive. Okay, now again, we're going to be looking on the right-hand side of the equation. Here we see a thing, and therefore we name the thing. What's being done here? Addition. Addition. We see the thing, and then we do the thing. So when you do the thing, you simplify. Simplify. Here we see a thing. That is what? That's division. So we label it. Oh my Lord, I can't spell. Division. And now here we do the thing. We see the thing, name it, do the thing, simplify. Simplify. Ta-da! So this one isn't that bad. If you'll notice, there's kind of a pattern here where simplify seems to alternate in between a lot of the steps. The only thing after that to keep an eye out for is for the distributive property. That will tend to sneak up on students. Now, just for kicks and giggles, the software will throw you something that has nothing really to do with pre-algebra until much later in Algebra 1, and that's absolute value. So, to begin, absolute value means has an actual definition. Absolute value. The technical definition, there's two definitions. There's the technical definition and the practical definition. The technical definition is distance from 0. Now, on paper, that sounds pretty abstract and a little bit like what? But here's the thing. Is distance ever negative? Think about that for a second. When you go to school on the bus, you go a certain distance. But when you get on the bus and then go home, do you go a negative distance? No. So the practical definition for absolute value is that you always make a number positive. The result of that is when you have a basic equation like this saying absolute value of x equals y, what happens now is that branches out and it gives you two answers. Y equals 5, yeah, sure, but because it's absolute value, whatever's inside gets spit out to be positive. Well, gosh and golly gee, -5 also spits out a positive number, so that's what they're expecting to do. If you had something like the absolute value of w equals 9, then your two answers are going to be 9 and -9. If you have over here absolute value of u equals 0, well, 0 is like the only number in the universe that doesn't have the sign, so the only answer you're going to get is u. What if you get something really hinky, like absolute value of, I don't know, y equals -8? Now, because the software will throw that at you, I couldn't find a screen grab of it, but when that software throws you at you, remember, it makes the number positive. Is that -8 positive? No. Ergo, this is going to be no solution. And it's no solution because absolute value always makes numbers positive, and since it does only positive things, the fact that there's a negative right in there, the absolute value is just like, nope, I am not going to interact with you. Next up, fraction word problem, losing a linear equation. So, I didn't give myself enough room. Boo. All right, so the drive is 12 miles long, finished 1/4. Let's see here. The big thing I want to keep and have you guys keep an eye out for is the 1/3, which is, hang on a second, but I'll talk about that in a second, because if I look at it now, I'm going to get distracted and then I'll confuse you. For now, 12 miles long, finished 1/4. When it's pretty straightforward like this is just multiplication. So 12 times 1/4, and that gets me 3. That's what we have so far. Let's see here. The which is the more important part, which is why I grabbed 2 iterations that had it, because this is where the actual algebra comes in, because now we have an actual equation. So far, she has saved $18. Which is, and I'm going to remind you guys in an earlier video, is your word for the equal sign. So when you see that which is, you know, oh, there's going to be an equal sign, which is 1/3 of the total cost of the game. So that's multiplication. We undo multiplication with division, so divide by 1/3, divide by 1/3, which honestly is just a fancy way of saying 18 times 3, which is, of course, going to be what? 54. That's just me doing the math in my head. Over here, we get to do it again. She has memorized 30 of the words, which is 5/6 of the list. So 5/6, so for a more complicated fraction like this, I remind you, we can break this into 2 steps. So we start with division, times 6 times 6. That gets me 5x equals 30 times 6, which is 180. Divide by 5, divide by 5. So therefore, x equals 36. There we go. So you have the normal thing that the problem will, you'll have the normal thing that the software will give you, which is just straight up multiplication. There's nothing fancy. Or they will give you the which is phrase, which is a little bit more algebraic. But again, you're going to be using calculators for this because I want to make sure that you can burn through the materials low-key kind of fast. Next, choosing stories that can be represented given one-step equations. So now we're backtracking to our one-steps because we want to make sure you understand the vocabulary of it first. So you'll see here, remember, it's worth translating. This is 4 times x is 28. And whenever you have the word for times, you can have words like per, for each, and for every, that's totally legible. What are you talking about? And what you're looking for is those kinds of phrases when you're looking at your options. So finished reading his book in 4 days. Each day he read X pages. So that one totally makes sense. Finished reading his books in X days. Each day he read 4 pages. That makes sense. A book is X pages long. He reads X pages. He has 28 pages remaining. Remaining means subtraction, and that's not what we're looking at here. A book has 2 parts. One part is X pages long. The other part is 4 pages long. The book has 28 pages. This is a total. So in other words, this is an addition problem. So therefore it's not it. And these are the only 2 that are our options. Over here now we have our operation, which is in fact X plus 11 is 44. Now, what are our words for plus? We have more than, we have increased. I don't think it'll be in this, but we have the word sum. Those are the kinds of words we're looking for. So Jenny is X years old, and in 11 more years, there's one of our keywords, she will be 44. So that's the one we want. Jenny is X years old. Josh is 11 years younger. Younger usually is a sign of subtraction. It's one of the lesser used words, but it's worth pointing out, so it's not that one. Josh is X years old. Jenny is 11 years older. There we go. If younger is subtraction, then older is addition. Jenny is 44 years old, so it's going to be this one. Josh is X years old, and 11 years ago, that's subtraction again, he was 44 years old. So there's only going to be 2 options for this one as well. So again, you have that little, it was a table in a prior video. You can look up that table and recopy it if you need to. Hopefully you still have your notes, weekly notebook checks, remember. And so if you have that table, you can help find your keywords that you're looking for when you're making your selections. Next, writing in the equation. Okay, so here's, if that looks familiar, that is your standard 2-step equation. That's one of the most common ways that it can be done. So we're looking again for our keywords from that vocab list. So let's see here. Frank orders some books online for $5 each. Each already tells me that's multiplication. That's where the variable is going to be. So I already know that there's a 5x somewhere. He paid a total tells me something of $4 for shipping. And then, oh, nope, that's the more important total. Total cost is going to be $89. So total cost, that's the more important one. That's our is, and that's going to be $89. And then total is another, it's one of those subtler words. It's a word for addition, plus 4. So now now that I've actually figured out all of the pieces, let's actually see what they want for here. And we can automatically see based on what we were pulling out from the equation, from the word problem, this is the format we're looking for. 5x plus 5b, excuse me, apparently they want a specific letter, who knew, equals 89. And now solve the equation. So if we're actually going to go through the effort of solving this, it's worth saying yet again, it's PEMDAS in reverse. So we start with our addition and subtraction to undo it. That plus 4 gets undone. Minus 4, so that means 5x equals 85. And now we move on to addition, multiplication and division. That's multiplication. The opposite of that is division. The opposite of that is division. X equals 17. And there's our final answer. We'll do one more, make sure everything's taken care of. let's see here. I'm not even reading. My eyes automatically jump to $4 each. So there's going to be my variable. And then discount. That's a hard one for kids to point out. Discount is one of your words for subtraction. So pull out the table of words that you found and add discount to it. So minus $5 off. And then spent. Spent is our verb. So therefore this is our equal sign, 71. All right, so that means because we have the subtraction, it's going to be this format. So 4b, I guess, being picky with their letters again, equals 71. And now we actually have to just go through the effort of solving the equation. So we undo our subtraction, plus 5, 4x equals 76. That's multiplication, so the opposite of that is division. The opposite of that is division. X equals 19. And there's your final answer. Not so bad. All right. Again, you want your table of words here for this. It will help you figure out where your key pieces of information are. Let's see here. Solving a decimal word problem using a linear equation. So now up here, we were getting used to the format. Down here, we actually have to make the format on our own. And specifically, they're throwing decimals at us because they want us to practice all of our other skills. So one of the things to keep in mind is, we were talking about this before, your variable is per, for each, and for every. Now, specific to this kind of format for a problem, you also will have the words base and start. Those are going to go into your B slot. They're the numbers that stand by themselves. So we have a base fee of $19.99. So good year. 1999 is our starting point, and then you have additional. Additional we know is plus, and then it's 96 cents for each mile driven. For each is our variable, so 0.96 cents for each mile driven, and then you have to pay finally the 270.55. They are going to make me use a calculator, aren't they? Oh, the horror, the horror. All right, to start with, we're going to move our 1999. It was a good year. 1999, that's a positive number, so we undo it with subtraction. 99. Had to party like it was 1999. Actually, no, y'all are too young. You're not going to get that joke because we all loved that song in the day. Anyway, can I do that in my head? I mean, I can, but can I do it quickly? That's going to be a 6. That's going to be a 5. That's going to be a 0. That's going to be a 7. And then there's the 2. Ooh, I can't do that quickly. Let me pull out my calculator. Hang on. All right, so let's just double check my math here. So we have 270.55 minus, what was it, 1999? 250. Okay, so I was a little bit off over here. Oops. And it is a 50. Oh, that's right, because I'm borrowing twice. And now I divide by the 0.96, and what do I get? 261. So x equal, oh, wait, sorry, didn't show my work. Divide by 0.96, divide by 0.96, and then x equals, what was it? 261. 261. That's our final answer. Now, again, there's another keyword to keep in mind here, and I've already seen it, and I'm going to highlight it here. Prepaid is one of your keywords, and I'm going to put this off to the side so we can draw attention to it. Whenever you see the word prepaid, or if you see the word gift card, this is the love part of the love-hate relationship with the software. If you see either of these two words specifically, that is a hint that you are doing subtraction. Traction. In normal pencil paper days, you're not guaranteed that. In fact, you would have any number of words that would mean subtraction, but because the ALEC software is in fact a software, the limits actually do a thing to help us. So whenever you see prepaid or gift card, it's subtraction. So we have our $20 to start, but then we're subtracting. Let's see here, it's 6 cents per, so there's our variable, 0.06 per yard. And then you have 18.14. So to start solving this, we move the 20 first. The 20 is positive, so we're going to subtract 20, subtract 20. So negative 0.06x. Let's see, 18.14 minus 20. t is 186. 1.86. And you'll notice it was negative. I probably did that too fast. Yes, it was negative 186. And now we divide by the negative 0.06. Divide by the negative 0.06. Divide by the negative 0.06 equals 31. X equals 31 yards. There we go. And then let's see here. Our last one, we have word problem involving consecutive integers. Consecutive is a word that I've known for so long that I forget that not all students know what that means. So consecutive means next to. So if you're looking at consecutive integers, think about something like 4, 5, and 6. They are consecutive because consecutive means next to each other. Next to each other. Now the thing about consecutive when you're dealing with algebra is how do you write that in terms of algebra? It's a fancy consecutive is a fancy word. We know that it's a signifier for something, but how do we actually write it? If something like sum means addition, then what does consecutive look like? That's the question you kind of want to ask yourself. So let's think about this 4, 5, and 6. How would we actually write them as if they were next to each other? We'll choose 4 and we'll pick the universe's favorite letter for algebra. We're going to say X. When we're looking at 5, how far away is 5 from 4? It's 1 away. So I would write X plus 1. How about 6? How far away is 6 from 4? It's 2 away. So that's going to become X plus 2. And that part right there is what becomes your important piece of information. That's what you're going to be zooming in on and constructing in order to make this equation. So you can see here I have 3 consecutive integers. That's X, X plus 1, and then X plus 2. Oh, it's the exact same amount. That's funny. And then the sum is 42. So how many X's are there? 1, 2, 3 X's. And then how many numbers are there? 1 plus 2, there's 3. And suddenly, without all that much in the way of thought, we have an equation, and now we're back on familiar ground. This is a 2-step. We've been solving this for the entire back half of goal 4. So let's start with undoing our addition. So we're going to subtract 3, 3x drops down and vibes, and that gives me 39. Next, that's multiplication. How do you undo multiplication? Division. We divide by 3. We divide by 3. X equals 13. And there's our number. There's a number, but is it the complete set? Because remember, it's 3 integers that we're looking for. So now, if x is our 13, what's x plus 1? 13 plus 1, 14. What's x plus 2? 13 plus 2, 15. So that's going to be the complete answer that we get, that we would expect it to be input into the software. 3 consecutive odd integers. New word. Now what does that mean? Have a sum of 27. So instead of having random consecutive integers like 4, 5, and 6, let's take a minute and think about 1, 3, 5. Again, how would I write that? If x is my 1, how far away is 3 from x? That's going to be 2 away. How far away is 5 from x, aka how far away is 5 from 1? That's going to be 4 away. So this will be 3 consecutive. So x plus 2, and then x plus 4. And then all of these add up to 27. We have 1, 2, 3 x's. And then 2 plus 4 is 6. And there's our equation, and now we're all set to solve. So we start with moving our 6 because that's addition. We undo that with subtraction, minus 6. That means 3x drops down. 27 minus 6 is 21. Now that's multiplication. We undo multiplication with division. 21 divided by 3 is 17. And remember, plug it in. We have the 17. What's 2 away from 17? 19. What's 4 away from 17? 21. So our complete list is 17, 19, and 21. And those are the 3 numbers we would input into the software. Is there anything after that? No, we're good. And so That is the actual last family for Pre-Algebra Goal 4. You are now officially DSA ready. Happy to go through all of the objective knowledge checks, go through both DSAs, and then move on to the tiny little smidge of topics that is Goal 5. Wish me luck. I'm going to try to do that all in one video. As always, stay happy, stay healthy, stay healthy, stay safe, and transmission.